Part D. All right, here we go. Part D. This time we're going to not manipulate a known, but we're just going to substitute into a known. So as I look at this f of x as the cosine of 2x, I want to substitute something into something that I know. And what do I know, or what should I know, is that the cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot. Okay, I might as well put the nth term in here. Negative 1 to the n, x to the 2n over 2n factorial plus dot dot dot. That's what we know. So now the cosine of 2x, I simply plug 2x in. So I have 1 minus 2x squared over 2 factorial plus 2x to the power 4 over 4 factorial minus 2x to the power of 6 over 6 factorial. I think you get the point. That's really what I'm looking for. Now if I write the nth term, negative 1 to the n, 2x to the 2n over 2n factorial plus dot dot dot. And there's a variety of ways you can simplify that. I'm happy with what we have. That's number 1. The second one, number 2, let's just say something like g of x equals e to the 3x. Again, what do I know? What should I know? A power series for e to the x is 1 plus x squared over 2 factorial plus x to the power of 3 over 3 factorial plus dot 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 plus x to the power of n over n factorial plus dot dot dot. And so now e to the 3x, you plug in the 3x. 1 plus 3x plus 3x squared over 2 factorial plus 3x cubed over 3 factorial plus dot 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 plus 3x to the power of n over n factorial dot dot dot. Pretty easy part D. Just substitute into a known. Now we're going to bridge into part 2, a little bit different and definitely a lengthy lesson. We're going to look at a polynomial for sine of x. So I know that the sine of x, again I keep saying but you should know, is going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, etc., etc. I'm going to write out a couple terms. 9th to the 9 factorial minus dot dot dot. So that's equals. Now it's only equals if I have this dot 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 at the end because it's an infinite series. Only the infinite series equals the sine of x. But suppose that I wanted a polynomial to approximate that. The order is going to be how many derivatives were taken. So if I have the 0 order, then that means the 0th derivative. So that would be f at 0. If I wanted the first order, then that would be f prime of 0. So that's how many derivatives I take. So a first order polynomial would be the order 0 term, which is 0, plus the first order term, which is just x. So I can say that the sine of x is approximately x. I can say that the sine of x is approximately x minus x cubed over 3 factorial. So this first one here would be a polynomial of order 1. And this one here would be a polynomial of order 3. So the question calls for a 7th order polynomial. So we are going to say that the sine of x is approximately a 7th order polynomial. You might be wondering degree, and a lot of times the degree and order do do align, they do match, but not always, so we just got to be careful about that. It's the 7th order, so it's going to equal x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, the end, no dot dot dot, no plus anything else. That's a 7th order polynomial. Okay, so how about a 4th order polynomial, Taylor polynomial for the cosine of x? Order and order 0, order 1, order 2, order 3, order 4. Just to write it kind of in a different way. So this would be the cosine of 0. This would be negative sine of 0. This would be negative cosine of 0, positive sine 0, cosine 0. But the thing is, I know what the cosine of x is. I should know the cosine of x. It's equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, that's a 4, minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial minus dot dot dot. Again, the dot 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 is the only way that I can write equals. So now I can say that the cosine of x is approximately a 4th order polynomial, which is going to be 1, that's like here 1, and then the coefficient of the next one is a 0, so that's why it's missing, minus x squared over 2 factorial, missing the 3rd degree because the order 3 is the coefficient of 0, plus x to the power of 4 over 4 factorial. That's it. There's a period at the end of that, not a plus dot dot dot. Let's take a look at this one. What if I asked for a 5th order polynomial? So a 5th order polynomial would be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. But then the 5th order is going to have a coefficient of 0, so there's no term there. So it turns out that the 5th order polynomial is also equal to the 4th order polynomial. And we're going to learn something about Taylor remainder theorem, so it's best to downgrade it as far as you can. So to take the 5th order, it's better to downgrade it to a 4th order for purposes that you will see later.